Welcome to Train Signal. This video is about internetworking. In this video, we'll go back and review briefly what an IP address is and how it's broken apart, so we can then take a look at what a router and default gateway are, and then I'll give you a basic introduction into subnetting. First, let's make sure we understand what an IP address is. An IP address is a 32-bit address which is divided into four 8-bit octets. We typically see it as four numbers separated by dots. The network ID portion of the IP address, which we know is always on the left, is what identifies what network a computer is on. Whereas the host ID, which is the right portion of the IP address, will uniquely identify the computer within that network. Let's take a look at an example. Here I have an IP address of 192.168.10.101. And as I mentioned before, we know that the network ID is on the left and the host ID is on the right. But we don't know how to divide it up by just looking at the IP address. We need to add in something called the subnet mask. The subnet mask is made up of 255s and zeros, and the 255s establish what portion is the network ID, and the 0, or zeros as it could be, would define what portion is the host ID. So in this example, 192.168.10 would then be the network ID, and 101 would be the host ID. Now it's very important to understand what network a computer is on when it comes to understanding internetworking. Now we'll come back to that in just a few minutes, but first we need to figure out what is this thing called a router. Well, a router is a device that forwards data packets along networks. A router is connected to at least two networks, blah, 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 blah. You thought I was going to read this whole screen to you, didn't you? Well, this is the type of definition you might find if you looked it up on the internet. But let me see if I can simplify this just a little bit more for you. See, a router is really nothing more than a device that allows communication between different networks. A host, or we could just simply say computer, like I have one little computer right here, only knows how to communicate with other hosts or computers on the same network. If this computer wants to communicate with a computer on a different network, it can only do so through the use of a router. Now, I've illustrated a few different examples of where routers are commonly used here. The first example I have here is really a simple network that's been divided into two network segments. This is common in many office environments where there's just too many computers to efficiently communicate on a single network. So when you divide into two or more network segments, you have to implement a router to allow communication between them. Another example I have here is where we have our office network and the internet network. Now that's two different networks where we use a router to allow communication between them. We have the same situation at home where we have our home network and the internet network, and again we have a router, but this time you'll notice very often they're referred to as cable modem routers or DSL routers. This is basically to simplify things for the average home user. The average home user who does not know a whole lot about technology knows that they have cable modem connectivity or DSL connectivity to the internet, so we label this router as a cable modem router or DSL router so they understand what they're buying, or at least understand that what they buy will get them out to the internet. Now, the last example we have here is where we have two different offices that need to communicate with one another. Now, there's really two versions of this example. One version is where I could draw a little cloud in here and call that the internet. This is probably the more common example in today's environments where both offices are connected to each other through something called a VPN or a virtual private network. Now don't worry a whole lot about VPNs and how to set them up. We'll cover that in another video. But for right now, just to understand how we would use routers, each office would have their own router to get to the internet to facilitate this VPN connectivity. Now, a VPN is not always used. In some instances, you will have a dedicated line, sometimes referred to as a T1 or a T3 line, between the two offices. In that set of circumstances, you would still have a router in each office to get connectivity to that T1 or T3 line to allow communication between the offices. All right, let me clear that out, and let's take a look at maybe a more typical office environment. Here we have our main office, and in our main office, it's a large network, and so it's been divided into many network segments. And here we have routers that have been put in place to separate connectivity between these network segments. Now, this last router that I circled here, you'll notice has more roles than just separating off to a different network segment. We also give connectivity to the internet, as well as connectivity with another router to a branch office. So one single router can serve many roles. So in this main office, we have a router to give connectivity to the internet and over to this branch office. Now, this branch office also has a router of its own to give connectivity directly to the internet. Now, this is done if this branch office was large enough to warrant direct internet connectivity. If it was a smaller office, then we may just get rid of this router here and use the main office to give connectivity out to the internet. We see both out there in the real world. Here we have another branch office with another router giving connectivity to the internet. Now, this time this branch office will only use the internet to gain connectivity with the main office. And then over here we have our home users. Again, not that unusual in today's corporate world. Many companies will have something called telecommuters, which is where we have people who work from home but need to be able to connect in with the office network. Or sometimes you even have somebody who is just out on an isolated task where they need to be away from the office. And in those environments, again, a router is used to gain access to the internet so that this home user could then get to the main office or really to either one of these branch offices. Whew, that's a mess. Let's clear that out of there. This is what a very typical corporate network would look like, with main offices, branch offices, and remote users. And as you can see, routers play a significant role in this typical corporate network. Matter of fact, it seems like it plays many roles, but really the one role a router plays is to allow connectivity between different networks. So what is a default gateway then? Well, see, computers can only communicate directly with other computers that are on the same network. Now, this has to be not only the same physical network, but the same logical network as well. And that's why it's so important to understand what the network ID of an IP address is because you have to know that two computers, if they're going to talk with one another, are on the same network, meaning having the same network ID. The only way for a computer to communicate with a computer from a different network, or one with a different network ID, is through a router. And this is what we call internetworking. Now, just so you're not confused, I know the word internet is here, and I know a lot of people like to look at this word and say, is the internet working? No, that's not how this is done. This is internetworking, meaning networking between networks. Now, the default gateway represents the IP address of a router that the computer is going to use to communicate outside of its network. So when we set up the default gateway on a computer, we are telling that computer, this is the IP address of a router that will help you talk to computers on other networks. Here I have a diagram of the basic network that I'm working on. We have the client machine that I'm working on right now with an IP address of 192.168.10.101 with a subnet mask of 255.255.255.0. Now I want to stop right there for a minute because I want to point out that having the 3 octets with 255 and 1 with 0, that means that our network ID is 192.168.10. And if we look down here to our server, we have an IP address and a subnet mask, which also shows that that machine is on the 192.168.10 network. Now let's focus in on the default gateways. My computer has a default gateway of 192.168.10.200, and you'll notice the server has the same default gateway. Why are they the same? Well, because we're both on the same network, and we're both going to use the same router to get off of that network. And you'll notice that that router's IP address is 192.168.10.200. One other significant piece of information I want you to notice is that the default gateway, or the router, is also on the 192.168.10 network. The default gateway must always be on the same network as the computer you're looking at. If the default gateway points to some other network, some different network, well, how's the computer going to get there? The computer needs its default gateway or router to get off of its network. If that router's already sitting over on another network, then we're going to just be stuck on our own network. We will not have a router available to get us off of that network. So let's go ahead and take a look at this computer and see its configuration. Alright, so here we are on our Vista One client computer, and what I want to do is go into our network connection. So I'm going to double click on our shortcut that we created in a previous video, and then we're going to go to the properties of our local area connection by right clicking and selecting properties, and then we're going to highlight TCP/IP version 4 and again select properties. And here you will see that we already are using the IP address 192.168.10.101 with a subnet mask of 255.255.255.0, but what's missing is a default gateway. So there's no way that I could communicate outside of this network without that default gateway. Now before I add the default gateway, I would like to demonstrate this for you. So what I'm going to do is I'm going to click on Start and go to the command prompt. And in the command prompt, I'm going to type in ping, which is a utility we use to establish connectivity. And I'm going to attempt to ping 192.168.1.1, which happens to be another machine on the network that I have here. But as you can see, it's, when I say network here in my office, but logically a different network because it's the 192.168.1 network. I'm going to go ahead and hit enter, and you'll see that we're getting errors. The ping transmit is failing. So let's go ahead and I'm going to minimize, click this little dash here on the command prompt, come back over here to our TCP/IP properties, and let's put in the default gateway of 192.168.10.200, which is the IP address of the router that we use to get off of the network that I'm on. So I'm going to click OK, and then I'm going to click Close, and I can even close our network connections window. Now I'm going to come back to our command prompt window, and the first thing I want to do is I'm going to type in ipconfig. Now this is another utility we use to display our IP configuration. And the reason I want to do this is because I want to see that the default gateway has been populated with our IP address, which it has been. Now that I know that that's in place, let me go ahead and type in ping 192.168.1.1 again, and this time you will notice that I am getting successful replies, meaning I am communicating outside of my network. Okay, so now that we know what a router and a default gateway is and how it helps us to communicate between networks, let me talk to you just a little bit here about the basics of something called subnetting. Now here it says subnetting is the process of taking a large network and dividing it into smaller networks to increase your efficiency and manageability. And of course we couldn't do this unless we had routers to separate these smaller networks. But let's take a look at how this works. Here I have an example of a network which is using the 172.16.0.0 network with a subnet mask of 255.255.0.0, meaning that this is a B-class network which can support over 65,000 hosts. Now, I don't know about you, but I find it quite impossible to try to manage one big block of 65,000 of anything. So what we want to do is we want to create smaller subnets from this large network, which will be much more manageable. Now the way we do this, let me clear that out, is remember with the subnet mask, we kind of have our little imaginary line that we get to draw between the 255s and the zeros. And we get to do the same thing with our network ID. Well, what we want to do is take our line and move it over to the right. So down here, you'll see that we now have a subnet mask of 255.255.255.0. 3 blocks of 255, 1 block of 0, which means I was now able to divide into 3 smaller subnets of 172.16.1, .2, and .3. Okay, now they're all within this original block, which is available to us, but these are 3 separate networks, each having 254 much more manageable hosts on the individual networks. This is one of the most common skills that an IT networking administrator needs to have. You need to know how to take a large block of addresses and break it down into a much smaller, manageable grouping for your individual networks. Alright, well, at this point, you should now understand routers and default gateways. And as a matter of fact, those two terms, they're pretty much the same thing, aren't they? The only difference is that a router is an actual networking device, and the default gateway is the IP address that you enter into a client to point to that device. And you should also now have a basic understanding of what subnetting is.